Hello friends, myself Rajendra Mahajan presenting my one more video on linear differential equation of nth order. Let us solve the problem. Solve differential equation d cube plus 1 into y is equal to e raised to x by 2 into sine of square root of 3 by 2 times x. Watch the video up to end for better understanding. The given differential equation is we call as equation number 1, and that equation is d cube plus 1 into y is equal to e raised to x by 2 multiplied by sine square root of 3 divided by 2 into x. Therefore, it is in the form of e raised to ax into v. Right hand side of that equation is e raised to ax into capital V, where the value of a as the coefficient of x in the term of e raised to ax, here it is 1 by 2, and v is sine of square root of 3 divided by 2 into x. And then we have obtained the CF and PI. Therefore, auxiliary equation is d cube plus 1 is equals to 0. A cubic equation, we have to obtain 3 different roots. Therefore, by solving synthetic division technique, writing the coefficient in decreasing order 1, 0, 0 and 1. Then checking for minus 1, we take the first element as it is. Why minus 1? Because the sum of even coefficient is equals to sum of the odd coefficient, therefore 1 as it is, and then multiplication of 1 into this minus 1, we get minus 1, sum is minus 1, again product as plus 1, sum is 1, product is minus 1, and last sum is 0, and therefore d is equal to minus 1 is the first root, and removing one factor from that, the remaining factor is d square minus d plus 1 is equals to 0. Quadratic equation. Solving it by formula minus b plus minus square root of b square minus 4ac divided by 2a. Therefore, here it is b is minus 1, minus of minus it becomes plus 1, plus minus root of 1 square is minus 1 square is 1, minus 4a1 c1 divided by 2. Then dividing by 2 separately, we get 1 by 2 plus minus square root of minus 3 divided by 2, and therefore it is 1 by 2 plus minus square root of minus 1 is I, therefore it is square root of root 3 divided by 2 into I. Imaginary roots, alpha is equal to 1 by 2, beta is equal to square root of 3 by 2, and therefore CF is C1 e raised to minus x for that real root. Then for imaginary, we write down e raised to alpha x means e raised to 1 by 2x multiplied by C2 cos of square root of 3 divided by 2 into x plus next constant C3 sine of square root of 3 divided by 2 into x. Therefore, we call this as equation number 2. Complementary function. 3 arbitrary constants C1, C2 and C3. And that given equation we call as equation number 1. This one as 1. Then in next part we have to obtain the value of pi by inverse operator technique. 1 upon f of d. F of d is here d cube plus 1, which we have to operate on e raised to x by 2 sine of square root of 3 divided by 2 x. As it is in the form of e raised to x into v shortcut method, we have to replace d by d plus a. A is here 1 by 2. Therefore, replacing d by d plus 1 by 2 throughout. And while writing the next step, we take that e raised to x by 2 before the operator. Therefore, it is e raised to x by 2, 1 upon d replaced by d plus 1 by 2 and its cube plus 1, which we have to operate on sine of square root of 3 divided by 2 times x. Expanding the bracket by a plus b whole cube. Expansion is a cube means d cube plus 3a square b, 3d square b is 1 by 2 plus 3ab square, 3d into 1 by 2 square, and plus b cube means 1 by 2 cube, and which we have to operate on sine square root of 3 by 2 times x. Simplifying it, e raised to x by 2 as it is, no change, 1 upon d cube we can write as d square into d, splitting that as d square into d, plus 1 by 2 into 3 means 3 by 2 times d square, plus 3 by 4 times d, and 1 by 2 cube means it is 1 by 8. And then operate it on sine of square root of 3 divided by 2 times x. As we are operating it on sine ax, we have to replace d square by minus a square. The value of a is here square root of 3 by 2 and its square. Therefore, replacing d square by minus 3 by 4. Wherever there is term of d square, replace it by minus 3 by 4. We get e raised to x by 2, 1 upon minus 3 by 4 times d plus 3 by 2 multiplied by minus 3 by 4 plus 3 by 4 times d, that term we keep as it is, and plus 1 by 8. Further, we have to simplify it. Sine into sine of root 3 by 2 times x, minus 3 by 4 times d and plus 3 by 4 times d, that two terms get cancelled, and therefore we have is equals to pi is equal to e raised to x by 2, no change, 1 upon, it is minus 9 by 8 and plus 1 by 8 multiplied by sine of square root of 3 divided by 2 times x. It is equals to e raised to x by 2, no change, we keep that term as it is, 1 upon 1 minus 9 we get minus 8 upon 8 and multiplied by sine of square root of 3 divided by 2 times x. Again simplifying, we get e raised to x by 2 with minus sign, sine of square root of 3 divided by 2 times x, and we call this equation number 3, pi, particular integral. Then the solution is given by y is equal to cf plus pi, complementary function, equation number 2, and pi is equation number 3, and therefore y is equal to, we get c1 e raised to minus x plus e raised to x by 2 multiplied by c2 cos of square root of 3 divided by 2 times x plus c3 sine of square root of 3 divided by 2 times x. And this is this cf, pi is minus e raised to x by 2 sine of square root of 3 divided by 2 times x. This is the required answer of that linear differential equation by shortcut method. If you like my video, please share it as well as subscribe to my channel If you are not subscribed yet, please subscribe it. And to receive the notification, please press the bell icon. Thank you. Thanks for watching.